Hello, today we are going to look at the composite properties for tangent. Yesterday we spent some time with the composite properties of sine and cosine, and today's objective is that we are going to be able to use those composite functions to get the composite functions for tangent, and then apply all composite properties to solve trig equations. All right, so just a refresher, these were the composite arguments that we looked at yesterday. We are going to use number 10 here and number 12 here in our first proof. So let's take a look at that one. So we have tangent of a minus b. So we know tangent is sine over cosine, so therefore tangent of a minus b is just going to be sine of a minus b over cosine of a minus b. Applying sine's composite property, we have sine of A is equal to sine of A cosine of B. Sine stays the same, so it's minus again. Cosine of A sine of B. And then we use the composite property for cosine. So cosine of A minus B is going to be cosine of A cosine of B. Remember that cosine switches signs, so now it's a plus sign here. Sine of A sine of B. All right, now comes the trick. I am going to take each side, each term, and divide by cosine of A, cosine of B. Okay, so look at each one of those terms there. And you can see cosine of A minus B, or sorry, cosine of A, cosine B. We took each term and divided by cosine A, cosine B. So that's the new stuff. All right, from there, we are now going to start to cancel stuff off. So you can see if I have a cosine B and a cosine B, that's gone. And if I have a cosine A and a cosine A, that's gone. And if I have a cosine A and a cosine A and a cosine B and a cosine B, all of that crosses off. And then nothing over here is going to cross off. All right, so what does that leave us with? That leaves us with sine of A over cosine of A minus sine of B cosine of B. All of this stuff was 1, and this stuff we had to leave the same. All right, since this is all about tangent, we're now going to turn those into tangent. So we know that sine of A over cosine of A is tangent of A. Sine of B over cosine of B is tangent B. And then sine of A over cosine of A is tangent A again. And sine of B over cosine B is tangent B. So we just proved the property for tan of A minus B. Okay, notice it's a minus sign on the top and a plus sign on the bottom. All right, now we're going to start from scratch and prove the second composite property of tangent. So now notice it's a plus sign on top and a minus sign on bottom. So it just kind of did the exact opposite of what the last one was. Right, minus on top, plus on bottom. All right, so let's start out with the same thing we did before. So I did tan of A plus B is the same thing as sine of A plus B over cosine of A plus B. Then the next thing we did was the composite properties. So remember the composite property for sine of A plus B is sine of A cosine of B. The sign stays the same, so it's still plus. And then it's going to be cosine of A sine of B. All right? And then we're going to take the composite property for cosine. So cosine of A cosine of B, and then we subtract. This is opposite, so this was plus, so this is minus. And then sine of A sine of B. All right, now we're going to take each one of those and do that same trick as we did on the other one, which was to divide by cosine of A, cosine of B. So we're going to take every single term. So let me rewrite the top as sine of A, cosine of B, plus cosine of A, sine of B. And on the bottom, I have cosine of A, cosine of B, minus sine of A, sine of B. And now we're going to take each one of those terms, all four of them, and divide by cosine of A, cosine of B. Cosine of A, cosine of B. All four terms. Okay, now we get to do the cross out. So cosine of B and cosine of B, cosine of A, cosine of A, cosine A, cosine A, cosine B. Everything goes there and nothing goes over here. All right, so what am I left with? I've got sine of A over cosine of A plus sine of B, cosine of B, all over. Remember, all this stuff canceled off, which left me with a 1. And I have the minus sign. And then I have sine of A, cosine of A, sine of B, cosine of B. And then one last step. What do those equal in terms of tangent? Well, sine over cosine is tangent, so that's tangent of A plus tangent of B all over 1 minus tangent of A, tangent of B. And we just proved the composite property for tangent of A minus B. All right, now let's take a look at solving some equations using our composite properties. Now we're going to get back to that last chapter we took care of. All right, so you would think, okay, I got to rewrite this as one function. So I can't have sine theta cosine 25 plus cosine theta sine 25. I've got to use my composite properties. So you want to look back at your composite properties that had sine and cosine, right? So those were going to be your sine properties. So sine A cosine B, sine A cosine B. And then, so we're either looking at 12 or 13, and then we just got to pay attention to the sign. So since it's plus, sine of A cosine of B plus cosine of A sine of B. This is equal to the composite property for sine of A plus B, right? So therefore, this is sine. A you can see is theta. So I put theta there. And B you can see is 25 degrees. Remember that the sign stays the same. All right, so this is a plus sign, so this stays a plus sign. And then it equals root 3 over 2. Now we're to our exact values. So you ask yourself sine of what function gives you root 3 over 2? Sine of what angle? All right, and you see that it's positive, so that tells you should be in the first quadrant and the second quadrant. And then your reference angle is 60 degrees. So therefore that's 60 and 120. So theta plus 25 degrees equals 60 degrees. And then remember, we could go around the circle infinitely many times. So we have to add on 360k, or we've used n, so I'll use that. And the other one we have is theta plus 25 degrees will equal the 120 plus 360 n. So to solve for theta, all I have to do now is subtract 25 from both sides, and I get theta equals 35 degrees plus 360 n. That is one of my generals. And then if I subtract 25 here, I will have theta equals 95 plus 360 n. That is my second general. And a lot of times they tell you to find the first solutions between 0 and 360. We call those particular solutions. And so in that case, if I went from 0 to 360, so I have 35 is one of them, right? If you add 360, you're over. So that's, and then 95 is the next one. All right, let's look at one more. So we have cosine of 4x, cosine of 2x, and a sine of 4x, sine of 2x. So now that cosines are both in the front and sines are in the back, now you know it's going to be the cosine properties. So you can see this is going to be cosine of A, cosine of B, minus cosine of A, oh sorry, sine of A, sine of B. And so what does that equal? That equals cosine of A plus B. They switch. All right, so in this case we have A is 4x and B is 2x. So therefore this is the same thing as saying cosine of 4x plus 2x equals 1. All right, then we solve it like we did last unit. So I do inverse cosine. And so I get 4x plus 2x, which we could probably say is 6x. And where does cosine equal 1? Cosine equals 1 right there. So it's 0 degrees, but we're doing radians now. So plus or minus, remember inverse cosine, you could do plus or minus. Not that plus or minus 0 is that helpful. And I don't want to do 360 because it's radians, so I'm going to do 2 pi n. And so I have 6x equals 0 plus 2 pi n. And then I divide everything by 6. Well, 0 divided by 6 is still 0. But now I have pi over 3 here. 2 6 reduces to pi thirds. And then I have my general solution. Okay, and if I want to find all my particulars, so from 0 to 2 pi usually, we put in 0 for n. So we get 0. And then we put 1 in and we be at pi thirds. And we just keep adding pi thirds. So if you have pi thirds plus pi thirds, you have 2 pi thirds. If you have 2 pi thirds plus pi thirds, now you have 3 pi thirds, which is the same thing as 1 pi. All right, keep going with that. Add another one. Now I'll be at 4 pi over 3. And last one will be at 5 pi over 3. Oh, not last one, because I add one more. And I'm at 6 pi over 3, which is 2 pi, which is where I should end. And those are the particulars. All right, next one, let's look at some tangent on the next video.